which is traffic light number 1 until 3, and the wake sensor. So we have one input and 3 output. The 3 output is traffic light system, traffic light which is color yellow, red, and green, and then input which is as a wake sensor. So the operation for this traffic light, for the initial state, the traffic light 1 and 2 always green, while traffic light 3 is red. So we know that number 1 and number 2 always green. So the other opposite traffic light, which is color red, then when there is a vehicle passing through a wake sensor, okay, so our input is a wake sensor, the traffic light 1 and 2 will turn yellow. So again, previously green, traffic light 1 and 2 become yellow right now for 3 seconds. Previously it's color green, then now turn to yellow for 3 seconds. Remember, 3 seconds only. After that, both traffic light, then after 3 seconds, both traffic light will turn red. Then when traffic light 1 and 2 turn red, when the traffic light 1 and 2 turn red, traffic light 3 will be green and stay for 10 seconds. This is for the traffic light 1, 2, and 3. So 1, 2, 3 become red for 10 seconds. Traffic light 3 become green for 10 seconds. Okay, clear? Clear so far?
Clear, sir.
Okay, then after 10 seconds, for this 10 seconds, traffic light 3 turn yellow. Previously, traffic light 3 it will be green. Then traffic light 3 become yellow for 3 seconds. Only for 3 seconds again. And after 3 seconds, it turn red. Okay, once traffic light 3 turn red, turn red, traffic light 1 and 2 will be turn green. So back to number 1. Once traffic light 1 and 2 turn green, then wait for input sensor. So it will return back to number 1, which is as an initial state. 1 and 2 always green, while traffic light 3 is red, and waiting for the wake sensor to detect any movement or any car below the sensor, the wake sensor. Okay, so the question, before we go to the question, look at the figure. So we have traffic light 1. Traffic light 1 have red, yellow, green, which is at the port 0, port 1, and port 2. So we have 3 port, which is port A, bit 0, port A, bit 1, port A, bit 2. Then traffic light 2, we have port A also, but bit number 3, and yellow at the port A, bit number 4, green, port A, bit number 5. So we have 0 until 5 bit of port A for the traffic light 1 and 2. But for the traffic light number 3, red, start the red with port B, bit 0, port B, bit 1, port B, bit 2. And the wake sensor will be on the port C. Wake sensor become as an input on the port C0. Remember, only port C0 is counted. Okay, clear? Clear so far?
Clear, sir.
Clear.
Okay, so the question is, assume that the signal on the wake sensor will be 1 when vehicle pass through the wake sensor, and the signal on the sensor will become 0 when it's no wake detected. So no vehicle become 0. When there is vehicle, sensor will detect 1. The traffic light will light up when signal 1 is given and off when signal 0 is given. So which means we are using active high for LED. So LED will be light if we supply 1 to the port A and B. Then the question asks, by using same crystal 6.144 megahertz, the create delay subroutine, only subroutine. Delay subroutine to make a 1 second delay. To make a 1 second delay using 6.144 megahertz crystal frequency. Create a program of delay subroutine by using assembly language. So we have to create a delay subroutine for 1 second. So this 1 second will be used later on this system for traffic light, which is to make a 3 second, 10 second delay. So to complete this question A, we have to refer back to our LED module, which is about the delay. Equal to the delay, LED module. So this is delay creation or input output by using PPI, peripheral interface. So the calculation delay here. So we go back to the basic calculation. Let's say we start with MBIC 255. So 255 is our decimal number, which is FF hexa. So it is equal to 8 bit. 8 bit na. So only 8 bit. So FFH equal to 255 in decimal. Then decrement C. So C become 254. Now C become 254 and jump to the loops. So the J and Z we check if decrementation here will trigger a zero flag on the flag register. Is it zero flag equal to 1? Because of our decrementation from 255 to 54 still not become 0, the zero flag will not trigger as a 1. So jump will be initiate again to the loop. Jump to the loop. Jump if not zero flag trigger. So loop will be, we go to decrement C. So decrement until 25, again 253 until become 0. So one decrementation becomes 0, J and Z will not always detected 1. Now it become 0. Once it becomes 0, so the loop will be failed. So you go to below of the program. So there is a program below this. Clear for the simple delay. Any question for the simple delay?
No, sir.
Okay, to calculate how many seconds for this simple delay, we have to use appendices from the final exam question or given on the e-learning lab. So let's say MVIC equal to 7 state, DCRC equal to 4 state, J and Z equal to 7 or 10 state. Okay, 10 state only will be used if condition is met. If condition is dipenuhi, met, we use 10 state. But the 7 will be used for the last state, which is not met. So here, to calculate, we have to add all the number of state here, including the loop here. So 7 plus 254. Why 254? Because the formulation said 255 must be minus by 1. So 255 here minus 1. We have one failed state. That one failed state we minus here, minus 1. So the yes state is 254. That's why we have 254. 254 inside the loop of DCR and J and Z. So DCRC have four state, and J and Z have 10 state, 10 or 7. For the yes state, condition met, we will use 10 state. So 4 plus 10, close the loop. Then the last state, which is fail state, 1 multiply by 4 plus 7. Why 7? 4 and 7 is 4 and 7. Why 7? Because of the last state is not met or fail state. The condition for J and Z, which is not met at the last state, which is 7 lah. So we use 7, 4 plus 7. So the total number, let's say 3574. So the total number of state, 3574. Okay, to calculate how many second this state machine we use here, we have to multiply by the crystal frequency state. So 6.144 over 1 over 0.5 crystal frequency, we have 325 nanosecond. So for the single time state at this frequency, 6.144 megahertz, we have 325 nanosecond for a single T state. But we have 3574, so we have to multiply with 3 to 5 nanosecond. So the total time state taken by this number of T state calculated here is 1.16 millisecond, for example, if the calculation is correct. So we have 1.16 millisecond for the maximum number of bit here, which is 8 bit. 255 is 8 bit. Previously we showed it. FF equal to 8 bit. So if when you want to use a longer time delay, let's say 1 second, so we have to use 16 bit. This is an example for longer delay. We can use either MVI or LSI. So I prefer to use LSI, which is the simplest or the shortest delay subroutine we can use. This delay subroutine can be memorized, or you can just practice, try memorize the instructions here. So to calculate delay for LSI, by using LSI, for example here, number B, we have delay LSI B, M. M is the number of what we want to replace here. So we want to know what is the value to be exact at the 1 second. 1 second delay. Previously from the question asked about 1 second delay. So to calculate how many number of M here, we have to equal with 1 second. So the calculation start with, let's go through the question. LSI BM have 10 state, DCXB have 6 state, MOV have 4 state, Aura 4 state, J and Z 7 or 10, return have 10 state. So we try calculate the whole value here by placing M with maximum number of number of bit, which is 0FFF, 0FFH equal to 16 bit lah. So we will use 16 bit here. 16 bit. So previously we used 8 bit. By using 8 bit, only can go up to 1.16 millisecond. So we try to use 16 bit. We replace with 0FFH. Then the calculation start by 10 state. So 10 state here. M minus 1, which is FFFH minus 1. So minus 1 in hexadecimal. So calculate by using calculator. We change to programmer FF FFF minus 1. We have FFFE, so equal to 65354. So the number M here, M minus 1 here, equal to 65534. So 65534 multiplied by 6 state plus 4 is 4 state, 4 state again, and the last inside the loop, inside the red loop here, we have 10, which is condition met. and close the loop. We close the loop. For the final state, which is a phase state, so we add with 6 again inside the loop, 6, 4, 4, and the final last state, which is not made. So the final state is 7. We use 7 and close the loop. After close loop, we add the last state, the last instruction, which is return, RET, equal to 10 state. So 10 state. So equal with how many total state we have here? Someone please calculate using your calculator, because my calculator here not very efficient. Can someone calculate using calculator? I would like to know how many total state if we use 65534 or 16-bit. Can someone try calculate? Oh, there is a question. Nur Anis, do you have any question? Ada soalan, Nur Anis? Nur Anis Atirah. Ada siapa tolong kira tak? Is anybody try calculate here? Six, 5,5,3,4 multiply by 6 plus 4 plus 4 plus 10. So plus again with 10 plus 6 plus 4 plus 7 plus the final return. So we have 3,999,574. Is it correct? 1376. 1376. 13764. Try calculate again. 65,534. Okay. My calculation here wrong here. I got wrong calculate. 65 again. 65534 multiply by 6 plus 4 plus 4 plus 10. So 1574, okay, plus 10, plus 6 plus 4 plus 7 plus 10 and the last 10. 1574853. Same with someone here. 137. Okay. 17283. Somehow my calculation 1572853. So we will use my value here. 1572853. Okay, so this is the total state number here. The total state number from calculated here. So this state we have 1,572,000. Let's say this is the correct one. Later on you try calculate again. So how to know how many second? To know how many second, we have to multiply with 325 nanosecond because of the frequency we use for the question in the exam, which is 6.14 megahertz. So total state we have 325 nanosecond lah. How to calculate? 1 of TS equal to 1 over 0.5 or half of the frequency, clock frequency. So half of the clock frequency invert in, or 1 over half of the crystal frequency lah. So we have 325 nanosecond. Remember nanosecond. Then this value we multiply with 325 exponential minus 9. So we have 0.511 second. So the value here equal to second. So we have the final delay for this 0FFF, we have 0.511 second. Let's say this is the correct one. So to get 1 second, we have to make a delay longer than this. To make a delay longer than this, we have to make a loop inside this delay. To make a loop inside this delay, we can use previous loop inside loop. For example, this. So this is number one. We have first loop. The dark color here is an loop number one, and the blue color is loop number two. So we have multiple loop here, and this multiple loop can be created by using same instruction MVI placed by value number two, because we have half of the second, which is 0.5 second. So to get 1 second, we have to multiply by 2. So multiply by 2, we can get 1 second. 1 second. So we can put here 2. So in short form, I show the question for the question previously. So we just modified the previous question by using LSI, full bit 8-bit, decrement same as the instruction, and to add another loop, so I put MVIB here. So this is MVIB as a two times as outer loop. So the inner loop using LSI, the outer loop we use MVI. So first we have to save PSW first, flat A, and also we have to save register A and flat register first. So we push inside the memory, then push register D and E, because register D and E will be used as a counter. So previous value in D will be saved first, and I replace B with number 2 because we want to make a 2 times loop for the basic loop here. So this is the basic loop for 16-bit. We want use to make a 1 second delay. So we have to calculate and make it become 2 times because previously we calculate 0.5, half of the second. So to make 1 second, we have to times by 2. To make times by 2, so I just loop in 2 times here. So loop LSI D with 0FF hash, then decrement D and E. So D and E, we can decrement -1. So move D into A. So or A with E. So we compare E and D here, is it become 0 after decrementation? If not 0, so J and Z we go to the loop. So go to loop again and decrement D and E. So D and E are still decreasing by 1 until the D and E become 0, because we compare E here, E and D. If E and D still not become 0, J and Z must be inside the loop. So we decrement until D and E become 0. Once D and E become 0, the outcome of aura E here, J and Z will trigger 0 flag. Once J and Z trigger 0 flag, once aura triggers 0 flag, J and Z will no longer use, because J and Z only check 0 flag not set. If 0 flag is set, this J and Z loop will not function again. So we terminate here and go to decrement B. So B here, previously number 2 will become a 1. So J and Z go to loop number 1, which is the first loop. So again, loop value 0FF hash to D, and also decrement again until it becomes 0 for 255, 60,535 times, because FF in hexadecimal 65,000, 64K. Then J and Z will become 0 once D and Z, once the decrement becomes 0, B becomes 0, J and Z will no longer use here. So we go to pop D. Why we pop D? Because we push D, the second one. We push the first PSW. Remember, push and pop will operate as a LIFO. Last in will be first out. So last in with D. So will be pop D first, and then pop PSW. So we retain the value of D and flag register. So we go to the return for from the previous program lah. Clear? So previously we calculate that 0FF we can get 0.5 second. By using loop, 2 times loop, we can get 1 second lah. By using 2 times loop. So we can complete 1 second. 1 second delay. So the question here asking about 1 second delay. So we can write down here. First, our calculated value. First is this one, and the second one is the value, the instruction here. Okay, is it okay? Okay tak? Push port tak perlu kira sekali ke? Okay, push port boleh kena kira sekali. Push port kira sekali. Tapi dia punya effect tu tak banyak sebab push port value dia 10 dengan 12 je. So push port kita kira sekali lah. We count as a number of total state here. Or you can replace 0FF here. 0FF ni, you can replace with M or X. So we can get the exact value of the state, the number of M here. We can get exact value M. Okay. Okay, for the question number 1. So you can again calculate how many seconds for this loop by replacing the value here to get exact 1 second lah. To get exact 1 second, you have to replace here with M. M is unknown in mathematics. So by looking for an unknown, equal it with 1 second, we can get the exact value of value here to be loaded inside this D and E register. Remember, LSID equal to pair register D and E. So we have 16-bit here. Okay. Then the question asks about construct a flowchart for the system. This is the whole system. Okay, to construct the system, let me write somewhere. Okay, to draw a flowchart, we have to go through direct instruction here or the question here. Okay. So the flowchart, we start with start. So start. Then for the initial state, traffic light 1 and 2 always green. So we say the initial state for traffic light 1, so traffic light 1 and 2 always green, equal to green. Always green. And while traffic light 3 always red lah. So traffic light 3 equal to red. So this is initial state. Then when there is a vehicle pass through wait sensor, traffic light 1 and 2 will turn yellow for 3 seconds. Okay, so now we have input reading. When there is a vehicle pass through the weight sensor, so we have to use input in trapezoid. Input equal to weight sensor read. So we read the weight sensor. Trapezoid is as the input output lah. So the square is a process. Square is a process. This is input output. Then followed by traffic light will turn yellow for 3 seconds if weight sensor detect. Okay, now we have decision. We have decision here. Decision in diamond. Weight sensor equal to 1. If yes, traffic light traffic light 1 and 2 will turn yellow. If yes, I have to put here. Traffic light 1 and 2 equal to yellow. And then delay turn yellow for 3 seconds. Delay 3 seconds lah. After that, both traffic light turn red. Okay, so delay 3 seconds. After 3 seconds, we turn red. This is yes. Yes. If no, it will return back to initial state. Ni no. If yes, we go down. Then traffic light 1, 2 turn red. And traffic light 3 will stay green. We green and stay for 10 seconds. Okay. Delay previously, traffic light 3 will be green. 1 and 2. Where is yellow? Weight sensor detect. Yellow after the jacket. Turn red. Okay, turn red. Here turn red. Traffic light 1 and 2 equal to red. After yellow 3 seconds, red. After red, when traffic light red, traffic light 3 will be green. Green. Traffic light 3 equal to green. Delay 10 seconds. Okay, so delay 10 seconds. Then after 10 seconds, traffic light 3 turn yellow. So after 10 seconds, this is junction connection to make a junction connection. After 10 seconds, traffic light 3 turn yellow. Traffic light 3 equal to yellow for 3 seconds and turn red. Delay 3 seconds and stay, then turn red and turn right. Traffic light 3 equal to red. Once traffic light 3 turn red, traffic light 1, 2 and turn green and wait for the input. Okay, so it return back to previous, which is here. So we return this one, we go here, and previous connection we go to here again. Something like that lah. You can do it in proper way. Boleh faham tak ni? Kalau jawapan TS total state itu kurang pada 0.5 second pun boleh. Dah walaupun kod tak ada push box. T-state kalau kurang 0.5 second. C-state kalau macam tadi kita calculate ini tadi kurang daripada let's say kita dapat kurang pada 0.5 tu, kurang sikit lah kot. Then kalau kita tambah push pop mungkin boleh dapat lah. Dia akan dapat lebih kurang 0.5 second lah, lebih kurang kita tambah push pop tu. Nak dapatkan exact value 1 second, nak dapatkan exact 1 second kat sini, kita cari value yang sepatutnya kat sini. Previously kita ganti dengan FFF0. Dengan FFF ni kita dapat almost 0.5 lah. Tapi kita nak 1 second. So untuk dapat 1 second tadi kita dah buat loop kan. 2 loop. 2 times loop lah. Macam ni. Kita dah buat loop, 2 loop tadi. 2 loop kepada basic 16 bit punya delay. So kalau nak dapat 1 second, yang ni kena replace exact value lah. Ada value yang sesuai. M lah. Yang ni kena calculate lah. Ini kena calculate. So kita dapat exact 1 second nanti. Kalau value M tu tepat lah. Okay, clear? Okay, then okay, yang flowchart ni, boleh faham flowchart ni? So, soalan ni kata, so initial state dia kata traffic light 1, 2 green, always green, traffic light 3 always red lah. Sebab once ia green, yang sepatutnya red. Then read input weight sensor akan check decision. If detect vehicle, if yes, detect vehicle, the traffic light 1, 2 always yellow and delay for 3 seconds. After that, both traffic light will turn red. Then turn red. 1, 2 turn red after 3 second delay. Then traffic light 3 will be green. Green and delay for 10 seconds. So 1 and 2 and also 3 will be delay is initial color, which is red. Initially red, then green will be delay in 10 seconds, and after delay 10 seconds, then traffic light 3 become 0. Once traffic light 3 become yellow. Once traffic light become yellow, ini yellow for 3 seconds, delay 3 seconds, and traffic light 3 will turn red after 3 second delay. Once traffic light turn red, traffic light 3 turn red, then traffic light 1 and 2 will be green. So this one will be continue to the previous loop, which is initial state. Initial state dah. So dia akan return balik ke sini. Clear? Clear tak? Okay, so to complete the program, the question asking about first delay, then we have construct the flowchart. Then using flowchart, develop assembly language program to control overall system. Okay, to use assembly language, so we just refer back our flowchart previously created. Then I just let's say this is our program. By referring to our flowchart here. So we use same exactly as our lab input output lab number 4 3 input output using PPI. So port A we equal to address number 80, B, C equal to 81, 82, and control port equal to 83. Then start with origin 2000 or 0, anything, you can start with any value. Then LSI stack pointer, because we want to use push and pop, so I will start the stack at the 3FF0H. Then move 81 to A as the initialization of input output for port A, port B, and port C. So send to the control port. Same exactly as a lab session lah. Then I will send 0000100100 in binary to port A. So this is will trigger traffic light number 1 and 2 in colored green, and traffic light 3 become red. So I will send A again with the 0001 or value 1 into the port B as the traffic light 3. Traffic light 3 in port B. So we send to bit number 0 to port B, and we will read the weight sensor at the port C. So we read the port C bit number 0. Which one? So in port C will read any value from port C and send to A register. So to check by using diamond shape, I will ani A previously input from port C with masking value, which is 1. So if switching here trigger 1, 1 and with 1 we produce 1 lah. So if switch here becomes 0, ani with 0, this instruction will trigger 0 flag. So let's say I will compare with A again. If value of input equal to the value of masking here, so compare A with the 1 value, which is our masking of uh, previously in port C, which is weight sensor. So by comparing A with 1, look back again to the instruction set. So by using compare 8-bit data, CMP, if A equal to data, 0 flag will set. Remember that if A equal to data, 0 flag will set. So again here, if compare A with the data equal to the A, 0 flag will set. So I will check the 0 flag here. Jump to TL if 0 flag is set. JZ equal to jump if 0 flag set. Jump to where? Jump to TL3. If 0 flag is set, we go to the TL3. So TL3 will run port A, which is turn yellow and delay 3 seconds. So out to port A, we call delay 3 seconds. So delay, previously we create delay 1 second. If we call 3 times, we get the 3 second delay. Kita akan dapat delay 3 second bila kita call, delay 3 kali. So we have 3 second delay here. Then after that, move to port A again to run port TL traffic light 1 and 2 to become red, traffic light 3 become green. So port A and port B, we send both value to get red and green at the port A and port B. So this one must be in 10 second delay and remain red and green in 10 seconds. That's why I call 10 loop, 10 decimal loop here. So we call the delay 1 second delay in 10 times. So saya panggil delay kat sini untuk buat 10 kali delay. Previously kita buat 3 kali, tak apa, kita tulis macam manual ni, tak perlu loop. So now we have 10 delay. You can also call 10 times here, but if 10 times easier for you to call delay, so you can call 10 times delay here. But right now I use delay loop. So they call 10 times delay here. If delay 10 times finish, then send to port A, send to port B to finish the last instruction, which is traffic light 3 become yellow and delay 3 seconds. That's why I call delay 3 seconds again. After finish traffic light turn red, then jump to main program. Again, start here. Start from initial state, which is traffic light 1, 2, green, traffic light 3, turn red. So we jump to the same instruction as previously and check switch. So the whole program here complete. So delay here, just copy gain from the previous subroutine. So that's why you have to calculate 1 second delay in previously. This is example to get almost 1 second delay. To calculate exact value of delay, you have to use calculation previously as shown here. Yang saya tunjuk kat sini ni, value kat sini kena calculate lah. Dapatkan exact value. So, complete question number 3. Any question? Ada soalan tak? Okay, remember, this question will be asked on your final exam lah. But maybe not exact same with this question lah. Some question design they need to calculate 0.5 millisecond or maybe 1 second. You have to calculate and can we get coding of the question? You can screenshot here. You can screenshot, or you can refer back to the recording. This is example of coding. This is example of coding. Ada soalan lagi? Boleh call 2 kali. Call 2 kali boleh. Tapi from the question ni minta using crystal disk, create a delay subroutine. Dia delay subroutine, ni this one we call delay subroutine. This one kita panggil delay subroutine. So kita tak boleh call kat sini sebab dia bukan dalam main program. Dalam main program kita boleh call 3 kali untuk dapatkan 3 second. Untuk subroutine dia minta dapatkan 1 second. So kita kena buat yang 1 second subroutine. So kalau kita buat yang ni, kita call kat sini tak boleh sebab kita bukan dalam call dalam main program. Kita nak subroutine tu 1 second. Soalan minta subroutine. So create a delay of subroutine. So nak kena buat subroutine tu 1 second. Baru dia dapat 8 markah ni. Even though you boleh call 2 kali, even nak dapat 2 second, 1 second sini, you boleh call 2 kali. Let's say dia call satu lagi, dia boleh dapat 1 second sini. Tapi tak dapat markah untuk ni lah, untuk subroutine. So kita buat subroutine untuk 1 second tu siap lah. Ni contoh ya, value ni bukan dapat 1 second ni contoh, examples. Benda ni subroutine ni boleh hafal je. Tak susah nak hafal. Push PSW kita nak stay kan PSW, ingat PSW ni flat dengan A register. Kita akan push A register dengan flat dalam memory supaya kita boleh simpan value dari flat asal ni. Then push D sebab kita nak pakai D kat sini. So push D. So value yang asal dalam D dia akan simpan dulu. Kita selamatkan D lah. Sebab kita nak guna D dekat LSI ni, nak decrement, increment nanti. So kat sini dia ada load value then decrement D and E. So move D to A untuk compare kan dengan aura nanti. So D dalam A sekarang ni, dia compare A dengan E. So dia akan compare lah kat dua ni. Then dia check if hasil aura ni, O ni become 0 not yet. Hasil decrement sebenarnya, hasil decrement ni dia compare adakah dah jadi 0. If not 0, go to loop again lah. So until become 0, then decrement B. Decrement B actually to run this loop second time lah. Because previously, let's say we have previously we have 0.5 second. So to get 1 second, we make it in 2 times loop. That's why ada MVIB ni, decrement B ni. So kalau nak dapatkan lagi longer, increment ni value MVI kat sini. Okay, clear? Okay, kalau tak ada soalan, kita adjourn our punya meeting ni. Kita stop meeting kat sini. Okay, terima kasih.